Alrighty then, it has been an interesting week when it comes to weather and space weather for that matter. Let's take a look at the closest star here, which has exhibited some additional coronal mass ejections. At least one significant one in the earthly vicinity. Sunspot 2860, which is this bright region down here, still capable of producing large flares, still indeed likely to. So we won't be able to exhaust any coronal mass ejection or solar flare warnings. They will remain in effect until further notice. Stay tuned to our channel for details. One of the best ways to analyze what's going on with the sun is to look at the magnetograms. So this SDO colorized magnetogram is one of the house favorites. Sunspot 2859 remains stable. So did Sunspot 2860. And when I say stable, I mean massive. And again, quite complex in its field makeup. Let's zoom in. And we saw a nearly M-class flare once again today while we did show prep. So a nearly M-class flare, a high-level C-class flare just happened. Also some coronal hole activity here around the solar equator. We'll look at a detailed analysis of that momentarily. That and much more on today's Daily Space Weather video. Coronal hole rotating in there in the southeast, as well as a possible new sunspot up here. We didn't see any umbre when we did show prep. We'll look at that in depth toward the end of the video as well, with some extremely high-res imagery. Here's a close-up of that area in 171 angstroms, my personal favorite wavelength. What's your favorite wavelength on the SDO data? Or even on other data? Let us know what your favorite wavelength is for viewing the sun. Mine's 171 angstroms. And keep in mind, these are all false color images, folks. This is all ultraviolet light. These are colored however they want. In fact, stereo A's 171 angstroms is in blue. Here's the southern hemisphere. Sunspot 2860. Our most interesting solar feature here for a few days. This is ionized helium and iron, 304 and 171 angstroms. One of our house favorite composite images. Just spectacular there. And if you didn't see our smAsho.org Presents the Sun series video yesterday, check it out. It's awesome. 10.7 centimeter radio flux still stalled at 90. And we're going to see a reduction in the sunspot number today. We only see 2 likely numbered groups at the moment. Also, NASA calling for some odd, actually NOAA rather, calling for some odd coronal mass ejection strikes here. I don't know what they're looking at. We're looking at the same data. And you can see right here, they're calling for a coronal mass ejection strike later in the day today or early tomorrow, and then another one on the kickoff of smAshtember. 9/1, September 1st, another small coronal mass ejection forecasted to strike by NOAA. I generally disagree with these. I don't know what they're looking at. I don't see these things as nearly as Earth-directed as this model shows. Geomagnetic conditions have calmed down here. We did see a minor storm recently, but there's the current state of affairs. Expecting another minor geomagnetic storm late tonight and early tomorrow. So here's what we're talking about. The most recent coronal mass ejection occurred yesterday. It's actually still happening as we make the video. Keep in mind the data here is a little bit old. It's about 10 o'clock Universal Time at the moment. And these videos are only showing up until about 3 o'clock Universal Time. So we got about 7-hour-old data there. There's the coronagraph and the difference imagery from stereo A, which is located out here at Lagrange point 5. It puts the sun to your right from that, it puts the Earth to your right from that perspective. Let's take a look at the viewpoint from Lagrange point 1. So Lagrange point 1 in between the Earth and Sun is where you'll find the SOHO spacecraft. It's where you'll find the C3 coronagraph, and we've put up a 6-day video here. If you want to bring up videos yourself for this, go to the Soho movie theater. So the LASCO C3 showing you here the last 6 days of coronal mass ejections, and there's been quite a few of them. None of them particularly Earth-directed. A couple little diffuse strikes. No major CMEs headed Earth's way, in my opinion. We also caught a sun-diving comet here. Check it out, right in this area. It's a pretty long video here. This is over 500 feet. Right there, you can see a sun-diving comet there. Looks like it accelerates and then breaks up as it approaches the sun. We'll let it play through one more time here. It'll be just around where my arrow's located there in the southwest. So great imagery there from the Soho LASCO C3 coronagraph. And that sun-diving comet occurred on the 27th if you want to go check it out for yourself. Let's take a quick look at global seismicity here. Pretty moderate activity there, nothing to write home about. There was a quake in the southwestern Mediterranean there, near Morocco. That was a 5.3. Let's go up the list. Looks like the South Sandwich Islands are finally calming down. There was a deep quake at Alaska. It's very small. A 4.2 deep quake at Afghanistan. That was nearly 200 kilometers depth. Indonesia saw one of the larger quakes in the past 24 at a 5.5 magnitude. Western South America saw a 5.3 at depth. That was 184.8 kilometers estimated depth. So the South Sandwich Islands are chilling out. Just moderate levels of seismicity here. Southwest Africa saw one. Southwest of Africa, rather. Near the African-Antarctican plate boundary. Tonga saw a 5.3. So pretty calm seismic conditions here. Let's check volcanoes. Shivaluch still erupting in an explosive fashion on the Kamchatka Peninsula, having produced a 14,000-foot plume of volcanic ash. Suwanosejima. So that's the only Kamchatkan volcano there. Little reduction in volcanic activity on Kamchatka. Suwanosejima, flight level 080. It's produced an 8,000-foot volcanic ash plume. Merapi, exploding 10,000-foot ash plume over central Java, Indonesia. Semeru over East Java, Indonesia, produced a 13,000-foot ash plume as it explodes. Semisopochnoi, ongoing eruptive activity. Explosive fashion has produced a 12,000-foot plume of volcanic ash. Fuego exploding 15,000-foot ash plume over Guatemala. Nevado del Ruiz, 21,000-foot ash plume as it explodes. That located in Colombia. Revenador producing an explosive 15,000-foot ash plume over Ecuador. Sabancaya exploding 24,000-foot ash plume over Peru. A great reminder to not pole vault the caldera. No matter how bad things get, check out smAsho.com. And by the way, we've recently updated the website. We'll be continuing to do that again and again. smAsho.com, you can find links to the Redbubble shop there. And I'm actually wearing one of the products now that you can find at our Redbubble shop. It's the Vaccinate This. My vaccination status is none of your business shirt. Here's a teaser. Again, you can find links to the Redbubble shop at smAsho.com. Thanks everybody who clicks, and welcome to the Neo Renaissance. Ghost magnetometer looking a little more normal here as the geomagnetic storm conditions have subsided. I'm not expecting them to return, although they are forecasting a geomagnetic storm, so we'll have to just keep an eye on it and see what happens. Anyway, that's a 3-day chart as measured by the GOES 16 and newly back online, the GOES 17 magnetometer. Let's take a look at the heliospheric current sheet. Earth is solidly in a North Pole current sheet. We are expecting to remain there probably up until tomorrow's video, or close to it, as there is a South Pole current sheet slowly sort of making its way here. Also, we'll be keeping an eye on that rising activity in the northeastern limb up here. So we don't see any major swings in this blue line here, which represents sort of the BZ component of the solar wind data. And there's the latest image from the line of sight ecliptic plane field plot. Line of sight coronal hole plot showing you the sun's B field in blue here. And we see some equatorial coronal holes, South Pole oriented ones. And cycle 25 takes its good old time progressing, folks. And here's our solar flare monitor and detected sunspot groups. I'm not so sure there's a sunspot here at where it lists 2861, but we'll show you high-res imagery at the end of the video. Again, likelihood of major flares is more likely than not at this point. Still over 50% because of sunspot 2860. It's quite a significant sunspot. KP index now down to 1, having reached geomagnetic storm conditions early in the day yesterday for a brief period. And we saw, like I said, we saw a C-class, nearly an M-class flare while we did show prep. There is the blackout over most of Africa there in the deabsorption region of the ionosphere, as radio signals are absorbed rather than refracted by the ionosphere. So here is your X-ray flux over the past 3 days, and you can see this nearly an M-class flare happened while we did show prep. Peak flux there was at 10 o'clock universal time. No spikes in the proton flux, no relativistic protons have been sent our way from any of the solar flares or CMEs. Here comes a real-time solar wind. And we're actually seeing a minor coronal mass ejection strike here once again, right in this area. So here you can see that the BTBZ and the phi angle shifted at the same time, that we saw this minor little uptick in the speed and the density. So that's a little tiny diffuse coronal mass ejection, barely noticeable in the signal. Current solar wind conditions are 4.5 protons per cubic centimeter for the density, 354 kilometers per second for the velocity. Here's the geospace model, the space weather modeling framework, and it's looking much more normal now. Plasma spheres back to a more normal size, not so compressed like they were yesterday. And this is 4 hours of data courtesy University of Michigan. The units modeled in this are nanopascals, magnetohydrodynamic pressure, and since it refreshed, we're going to let it run through because we don't edit these videos. We put them up as quickly as possible, and when I make mistakes, I just try to correct myself. And you can see a bit of a subsiding of the pressure here toward the end of the movie. Next, ground magnetic perturbations. And again, we've seen geomagnetic conditions calm down. We don't expect to see major perturbations here. Since there is a pole excursion going on, the South Pole someplace down here. The North Pole is someplace up here. Continuing on, there's a diagram of the solar system. No, planetary alignments don't affect much of anything, if you're wondering. Let's advance this 1 week. There's where things will be in 7 days. Approaching another new moon, my favorite phase. Did you know that I'm a reverse werewolf? Yeah, it's true. When there's a new moon, I sleep well, and I eat well, as opposed to going out in the middle of the night, staying up all night and eating people. They don't taste good. I don't know for sure, folks. I haven't eaten people, if you're wondering. Here's a star chart. The moon is near its apex. We've got a a waning moon at the moment. The sun just rose here in Lehigh Valley. This is in-the-sky.org star chart. And the yellow line you see there is the ecliptic plane, the path the sun will take across the sky. The blue line is the galactic plane. Sun crossing the galactic plane between Gemini and Taurus. OMG. We're going to skip a cosmology segment. We're looking to do an extended one. We hope to do that later today if all goes well. And since this figures into space weather, now's our time to show the astronomy picture of the day. You can find it yourself at apod.nasa.gov. And these are the paths of potentially dangerous objects in the solar system, things like asteroids. And there are various different groups of asteroids that orbit different locations in the solar system. Quite a few potentially hazardous asteroids around. A great plot of all those objects. Again, apod.nasa.gov if you want to check it out yourself. A great image there for all of you asteroid followers. We've got some relativistic electrons causing some internal charging hazards. So surface charging hazards are caused by low energy electrons. Internal charging is caused by higher energy electrons, and we saw electron flux reach quite high levels yesterday. They've now subsided a bit. We'll show you that in a moment. And this can cause some communications errors. What happens is the internal charging scenario can cause a buildup inside the equipment. It can cause a discharge and cause all kinds of errors on geosynchronous satellites. That's why we show that. Here is the relativistic electron flux, and you can see that sudden spike there in the greater than 2 mega electron volt electron flux. So this level right here is over 10 times warning levels. Warning levels start at 1,000 pulse flux units. That's 10,000 pulse flux units. And they've dropped down to a little bit lower levels here. But we may see similar levels today as we saw yesterday. So here's the forecast model, and you can see NOAA tends to agree with me here. Just slightly lower levels. And look how far off they were with the forecast there. It happens to the best of us, folks. I was not responsible for that forecast, however. Here's a diagram of Earth Van Allen belts to remind us what we're looking at. And here's the total electron content forecast. This will show you where the most likely GPS errors will occur, which is, of course, for you new viewers, typically around the equator at noon. Nothing too anomalous showing up here on the total electron content forecast. Here's another diagram to show the ionosphere, which is located right there. Well, different layers of the ionosphere. There's the D layer that we talked about earlier in the deabsorption region. Above that, you've got the E layer and the F layer. That is where the electron flux, proton flux, and all kinds of other measurements, the GOES magnetometer, and so on. So here is the ionosphere map. And we do see some significant anomalies here, both on the high and low frequency sides. Keep in mind, as we approach equinoxes, the Earth becomes more geomagnetic. There's more activity around the equinoxes because of the orientation of the Earth's axis and the way the fields are oriented. Here's the latest ionogram from 10:45 Universal Time. Here's the anomaly map. This shows difference in megahertz. I had to reload that. This is the anomaly from the 30-day median. It shows the difference in megahertz off of the 30-day average, or mean, or median, or whatever you statistically like to call it. Again, we see some high and some low frequency anomalies here. And let's bring up the latest image. There's 10:45 Universal Time. Things looking pretty normal there at the moment. All right, and we've done another Berserk meteorology segment. Make sure you check out our playlists, youtube.com/smashamash/playlists. And I don't see a sunspot over here, so I'm going to say there are only two sunspot groups right now. Sunspot 2859, which is right there, looking pretty weak, looking like an alpha class sunspot, and sunspot 2860, which is quite complex, and again, likely to produce major flares. Here's the latest colorized magnetogram refresh. Oh yeah, this active region, certainly not a sunspot yet. Sunspot 2860, yeah, really complex, really likely to produce additional major flares and possible coronal mass ejections. By the way, we've got hours and hours of streaming coverage on twitch.tv/smAsho. And last night's spectacular coronal mass ejection was captured once again on the channel, twitch.tv/smAsho. Highly recommend you subscribe over there. We regularly do live streams. We even streamed our meteorology segment. And our meteorology segments typically air just before the daily space weather video. We've also captured this C-class flare here. You can see that little brightening there. That is the nearly M-class flare that happened while we did show prep. Shout out to the sun. Next, some more bonus features, the El Teide Observatory. And this is a ground-based solar observatory in El Teide, Spain. Again, there is a coronal mass ejection going on while we're making the video. And yeah, this data is only 4 minutes old. You can actually see one of the filaments here. Just take note the time and date stamps, folks. And here's some additional imagery. It's the southern hemisphere in 304 and 94 angstroms, which is ionized helium and iron. Again, there's an active region rising. It doesn't look like a sunspot. I don't think it is a sunspot. But some great imagery nonetheless. And last but not least, here's a full disk view of El Sol. If you've got comments to leave directly for the sun, leave them in our comments section. If you think the sun's conscious, leave a comment. And I'm not sure if the sun reads our comments or not. Perhaps we'll send it an email and ask. Little bit of sudden activity up here, too. Little outburst-looking event happening right up here. Just a sudden intensification there in ionized iron, 171 angstroms. Anyway, we are out. Thanks again for tuning in. And may that solar wind be at your back.